In this video, we are going to do the stock price prediction using the LSTM neural network. So LSTM is a little advanced version of the traditional recurrent neural network. So the LSTM has the full form of LSTM is long short-term memory. So mostly it is used in the tasks like predicting the next move using the previous data. So it has a feedback loop. That is why we are going to use the LSTM neural network. Now, in the first cell, as you can see, I have imported all the required libraries: NumPy, Pandas, Matplotlib, Keras, and TensorFlow, etc. etc. So we are going to use the data of Microsoft stock. So the data set that we have, again, it's that usual OH, LC, and volume data that we're going to use. So the first column is the date and open price for the day, high price for the day, low price for the day, close for that day and adjusted close, and volume, number of shares traded on that day. So this is the data set that we are going to use. Now the next thing that I'm going to do is I'll visualize the close price of the stock and I'll get the general idea about the stock price. So here I'm going to use Matplotlib. The figure size, let's keep 16 and 8. So the title will be the closing price of the stock and DF of close. So on the x-axis we have the data about the stock and the closing price is on the y-axis. So the stock is been a significant multi-bagger. It started its journey from around less than $1 and now it's trading about $300. So it's a very nice stock that has given decent returns. So we got a basic overview about the stock price performance. So let's do df.shape and we'll see that we have 9083 rows, data points, and 7 columns. Now we'll create a new database with only required columns. So data will be df of filter of close. Now we are only working with the close price of the day for that Microsoft stock. Now convert this data frame into a NumPy array. So data set will be data.values. We'll extract only the values from the data frame. Get the number of rows to train 80% of the data. So training data length will be math.ceiling function and we'll multiply this length of data set with 0.8. So we'll get the number of rows to train 80% of data. So 80% will be 7267. Now the next thing that we are going to do is we'll scale the data. So whenever you're working with neural networks, it is a good practice to scale the data. If you do not scale the data, probably the performance of neural network will not be that good. So we are going to use standard scaler. So I'm going to create one instance of the standard scaler, and scale data will be, I'll use the fit transform function. So in the fit transform function, I'll give the data set and this will be stored into the scaled data variable. So as the standard scaler works, the mean of the data will be 0 to 1 and the standard deviation will be exactly 1. So as you can see, a mean of the new processed data is this, between 0 to 1, and the standard deviation of the processed data is 1. So now we are done with the scaling part. Now we'll create the training data set from the scaled training data. So trained data will be scaled data 0 to the training data of length. So we created the training scaled data. We'll split the data into X train and Y train. So X train, Y train, we split the data. Now convert your X train and Y train into NumPy arrays. So np.array function we can use. So np.array of X train will be stored into the normal X train, and np.array will give Y train and it will be stored into Y train. So we have the X train and Y train converted into NumPy arrays. Now we'll reshape the data. So if we do like print X train shape before reshaping, so the shape of X train is this, and after reshaping we have this shape. So we'll reshape the data. Now we'll build the LSTM model. So again we are going to use the sequential model. So firstly I'm going to add first LSTM layer and of 200 neurons, and we'll give X train, the shape of the X train is input, number of input neurons. So the input shape will be X train of a number of features present in X train, that will be an input shape, and I'm going to add two LSTM layers of 200 and 200. So these are two LSTM layers and we are going to use the sequential model. After adding two LSTM layers, I'm going to add two dense layers. The first dense layer will have 100 neurons. The second dense layer will have 50 neurons. After that, we'll have again one dense layer for the output. So now this is the LSTM model that we're going to build using sequential. Now we'll compile the model, and the optimizer that we are going to use here is the Adam, and the loss metric will be mean squared error, since we are solving like a regression problem. So model dot summary. So this is the summary of the model that we have built. So it is a sequential model. These are all the layer types, the output shape, and number of trainable parameters. So first is our LSTM layer, and this is the output shape. Again LSTM layer with 200, dense layer of 100, again dense layer of 50, and final dense layer of 1. So total trainable parameters are 507601. So here we are done with building our model. Now let's train the model. So I'll do one thing, I'll make one variable called history, and I'll do model.fit, and I'll use xtrain and ytrain, and here I am initially training this model with 5 epochs. You can increase the number of epochs for better performance of the model. So I'm training the model with 5 epochs, and you can see I'll plot the history of loss. So the loss is constantly reducing after every epoch. Now, so this is the plot for loss. The next thing I'm going to do is create the testing data set. So we'll create a new array. Test data is equal to scale data of training data len minus 60 and all columns. So create data set xtest and ytest, xtest and ytest. Now convert the data into numpy array. So xtest equals to numpy array of xtest. Will reshape the data and will get the model predictions. So predictions will be a model dot predict function, and will check the predictions on xtest, and finally will print the predictions that are made by the model. So these are all the predictions for the stock price on xtest that are made by the model. So this was the entire stock price prediction using LSTM. We used Microsoft data using the LSTM neural network to predict it. I hope you are clear with this video. Now let's move to the next concept. Thank you.